There's a quiz on Tuesday. And it will, yes, Kevin?
So when's the quiz?
The quiz is on Tuesday, okay? And it's going to cover everything that we've learned up to and including class today. Right? So,
Professor,
yep.
What's the quiz going to be on?
So basically, everything that we covered up to and including class today.
Dr. S, when does this class end?
2:30?
Professor, the quiz is on
I think she said Wednesday.
Wednesday.
Well, I think it was Wednesday, yeah.
No, I think it's Monday.
Oh, Monday? Oh.
I think it's Monday.
Okay, let's think about what was happening there. The real problem was information, like the quiz being on Tuesday, was going into the students' heads. They just weren't saving it in their memory. Therefore, they had no way to retrieve that information later. Who knows what was really happening to it? Maybe, or possibly, whatever it was that was happening to the information when it went into their head, it was definitely not getting stored in memory. What they really needed was to have some location in their brain that had a label associated with it, like day of quiz. And then when they heard the day of the quiz, Tuesday, they could save that information in that memory location. That way they could retrieve it later. They'd look for the label day of quiz somewhere in their mind, and they would see the information, Tuesday. Now, is that the way the human mind really works? I don't know. But it is the way computer memory really works. You can think of computer memory as a long list of locations, each of which can save a piece of information, and it can be stored there to be used later. Each of those slots has an address associated with it, which is used basically as a label so that we can say this location is at this particular address. Now in computer memory, those addresses or labels are going to be long sequences of ones and zeros. Now, as you can imagine, it would be really painful to write a program where you refer to computer memory locations by long sequences of ones and zeros. Who wants to do that? And it turns out in programming languages, you don't need to do that because programming languages provide a very simple way around it. What they do is they provide an element that's called a variable. And a variable is just a name that you use in your program to refer to a specific piece of information that you want stored in memory. The computer worries about associating the variable name you give in your program to some specific place in memory where the data would be stored. You never have to worry about it. The programming language itself lets you just use that variable name, and the computer will automatically look through its memory and find the space associated with that variable name, and as a result, the information that's stored at that location that can be used later in calculations, displaying it on the screen, saving the information to a file, whatever you want to do. So, for example, in a program, you could create a variable called day of quiz. Your program could then instruct the computer to put the value Tuesday in the memory location associated with day of quiz. It would be saved there for your program to use later. So for instance, you might then issue a request to the computer to output or display on the screen the contents of the variable day of quiz. The computer would look up the location in memory associated with that variable name and, according to your instructions, print it on the screen, which would cause Tuesday to be displayed. It's as simple as that. Saving information in memory and using a variable name to access it allows you to have the information there to manipulate however you choose in your program.
So, day of quiz.
Tuesday. It's as simple as that. Variables allow you, in your program, to create meaningful names by which to refer to data that you want to manipulate as part of your program. Python, like all programming languages, however, puts some restrictions on how you can specify a variable name. The rules for forming variable names in Python are the following. It's valid to have upper or lowercase letters in a variable name. It's valid to have numbers in a variable name as long as it's not in the first position, because if your variable name started with a number, Python might think you meant to type a number but accidentally typed a letter in it. So again, variable names cannot have a number as their first character. You can also have the special character underscore as part of a variable name. Typically, you use underscore in places in the variable name where you might want to actually use a blank, which leads us to our next set of rules, things that cannot be in variable names. You cannot have blanks in variable names. You cannot have special characters other than the underscore. So for instance, you couldn't have a % sign or a question mark or an exclamation point. And also, a variable name cannot be a keyword that's in Python. And a keyword simply is a word that has special meaning to Python. But we're going to talk about those later. Okay, so let's try a couple of practice variable names to see if you got the rules. Is limit 100 a valid variable name? Yes, it contains upper and lowercase letters, which are fine, and numbers, and the numbers are not in the first position. Now, how about tax %? Is that valid? No, it's not valid because it has the % sign in it. And remember, our variables cannot contain characters other than numbers and letters except for the underscore. So finally, how about max weight? That one is also invalid because it has a blank space in it. This is an example where using the underscore actually comes in handy. You can use it in place of blanks, changing max weight into max underscore weight, which would be a valid variable name and pretty much just as easy to read. There's another thing about variable names. Python doesn't care what you name your variables. As long as they're valid, Python is going to be happy. However, in Python, like most programming languages, there are what are called naming conventions. No, not that kind of convention. It means that all the humans who program in Python have gotten together and kind of come up with some standards in terms of how variable names are going to be formed. In Python, the standard is that variable names should consist of all lowercase letters, such as the variable temp, or if a variable name is really made up of a sequence of words, those words should be connected with underscores. For example, total score. There's also another convention when it comes to naming variables, and that is if you have a variable whose value logically should not change in your program, convention is to have that variable name all in uppercase letters. So for example, let's assume you have a variable in your program called year born. And once some initial value has been assigned to it, its value, according to the logic of your program, should never change. That's the kind of variable name that should be in all uppercase letters. So someone looking at your code realizes that that variable's value should, according to the logic of your program, not be changed once it has been assigned some initial value. Even though Python doesn't care, it will make your programs much easier to understand, maintain, and debug. Now, there's one thing about variable naming that really is a matter of style, and that's how long and detailed you make your variable names. Some people like to make them very long and detailed, some abbreviate a little bit. Assume in a program you wanted to have a variable that would hold the maximum room capacity. You might name that variable max room cap, or you could name it maximum room capacity. Both are acceptable. It really is just a matter of style. Just don't name it something like MRC or M. No one is going to thank you for that, including you if you have to look at your code 6 months later and try to remember what M stood for. So, it's the modern age. Give your variables meaningful names. Everyone will be happier for it, even if Python doesn't care.